everyone. Thank you again for coming tonight. We're really looking forward to Nicholas de Monchaux's talk this evening. I'm David Bates, the director of the Berkeley Center for New Media. I just wanted to say how important ATC, the Art, Technology, Culture Colloquium, is for our research center, which is housed in this beautiful Siddhartha Dai building, and we're really pleased to be here as part of the CITRIS Information Technology Research in the Interests of Society. And that's what we do best, is really bring together people that are working at the leading edge of technology, the art and design world, and also the world of the humanities and the social sciences. So I just wanted to say that ATC is not only our signature lecture series for BCNM, but it's also a very important part of our graduate program. And we run a very interesting seminar that all of our students in new media take every year that parallels this lecture series. So it's really not only a good way for BCNM to reach out to the community, but it's also extremely important for bringing together people on campus. So I also wanted to mention that tonight is especially important because our speaker is not only an affiliated faculty member of new media, but also one of our core faculty who work on our executive committee. And I think a real good exemplar of the kind of both students and faculty that we try to draw to the center. Somebody who's really very, very deeply immersed in their own discipline, but also extremely open to working across the disciplinary boundaries. So just wanted to welcome from BCNM's perspective, Nicholas, to tonight's series. So I'll let Ken Goldberg tell you more about Nicholas and ATC, and enjoy tonight's talk.
Thank you. Thank you, David. So I want to welcome all of you to tonight's sold-out performance of the Berkeley Art, Technology, and Culture Symposium. Before we begin, I'd like to just announce 4 upcoming events. First of all, on Thursday and Friday, we're doing something special called the Crossing Boundaries. Let me see where it's let me get the title exactly right. News, Technology, and Audiences. And this is going to be an event that's co-sponsored with CITRIS and a number of other institutions looking at the idea of international news in the context of new media. So there's some flyers outside, and if you want more information, please find us right after the presentation. Also, I want to make a special announcement that we have a brand new addition to the ATC series lineup that just basically was confirmed yesterday, which is that Sophie Calle, the performance artist from Paris, will be making a surprise appearance on March 28th. This is just about 2 weeks from tonight, and it will be a special time, which will be 5:30 to 6:30 p.m. here in this room. And so please join us if you're available. She's going to be talking about some of her work and answering questions, and it's one of her rare appearances in the United States. Also, on 25th of April, Raf D'Andrea will be presenting, and he is a roboticist and a sculptor who does robotic sculptures that are phenomenal. And on 2nd of May, we have Christopher Alexander, who is the renowned architect, visionary architect he has spent many years here at Berkeley, now lives in London, and this is going to be his first West Coast appearance in over a decade. So that will be directly on this evening at the 7:30 p.m. time slot. So I want to thank everyone involved with the Berkeley Center for New Media, David and Susan and Ashley and all of the staff and faculty who are involved with making this program possible. We're very fortunate to have the speaker that we have tonight. He's one of our own, and I'm very proud of that. In fact, I want to acknowledge another member of the Berkeley community tonight, which is the Owsley Stanley, who was a UC Berkeley alum, who in 1965 to 1967 was making huge batches of LSD just outside the Berkeley campus. I think he does deserve our applause for changing our image of the world in fascinating ways. And he is a Berkeley alum. He passed away this weekend, and he will be missed. But while he was doing that, NASA and the military-industrial academic complex was busy cooking up another equally far-out project, which was the Apollo space mission. And anyone who has watched with horror in the last few days the videos coming out of northern Japan, of the sea just surging over the embankments and sweeping away structures, buildings, it's an immense tribute to the staggering power that the soft ocean can have over hard concrete structures. And this is one of the topics that Nicholas is going to address tonight. It's the idea of, it's the dichotomy between hard and soft, and many of the often gendered biases and assumptions that accompany those two particular polarities. So tonight we're going to hear a cautionary tale of technology and culture that has never been told and won't be known until the public, until his book comes out, which is approximately
2 days.
2 days. It's a tale of hard science and soft science, about fact and fiction, and about whether we should design our bodies for outer space or design outer space to suit our bodies. It's about the new look in design, and yes, Christian Dior, pre-Galiano. Makes an appearance in this tonight's lecture. And there's many more interesting cast of characters which you're about to hear about. I want to say something about Nicholas. He's a good friend. He's a colleague. He is a wonderful member of the executive committee of the Berkeley Center for New Media. He has been doing interdisciplinary design work on looking at cities, networks, and nature for the past 2 decades. He has a BA in architecture from Yale and an MA from Princeton. He was a special assistant to Diller and Scofidio for many years, and then was a professor at the University of Virginia before we were able to attract him here to Berkeley, where he's become one of our stars and has been teaching terrific courses, writing, performing his own practice, and most recently his local codes project, which I hope he'll touch on tonight, has been hailed in a number of venues, including an architectural biennale that was held in Denver. And he's also been a Guggenheim Fellow at no less than the National Air and Space Museum. He's worked in Venice, Italy. He has been heralded by the American Academy in Rome. He is truly an international individual, and he grew up at MIT, and we are delighted to welcome him here tonight. Please welcome Nicholas.
Well, thank you all so much for coming tonight. I really want to thank BCNM and Berkeley, who have provided, Berkeley has provided the home to the conclusion of this project. I stand here before you tonight slightly in shock because I think it's literally been 8 years that this project has been in some form of gestation. And the notion that one might actually be able to pick up a physical copy of this book in no less than 2 days is really astounding to me, and reflects not really even my own efforts, but the efforts of all of those who helped me with the project, some of whom are here in the audience tonight, some of whom, my wife and son especially, ended up having to stay home tonight, so I want to thank them publicly, especially in their absence. I won't, it is often the case in a lecture by an architect that you get a kind of theoretical and historical preface to a presentation of design work with the presumption or inference that the design work somehow lives up to and channels the power of the history and the ideas that have been previewed before it. I'm not even going to try and do that with this material. I don't think I could ever follow up the story I'm about to tell you, but I will make a slight plug for an event tomorrow night, an opening at SPUR, the San Francisco Planning and Urban Research Association, at their gallery on Mission Street. I will open a show of 300 models and 1,500 different drawings of designs for peripheral and leftover vacant lots in the city of San Francisco, which is part of a larger project called Local Code Real Estates, which deals very much with the themes of information, hardness, softness, resilience, robustness, and how to live for the future that I will touch on in the rest of the lecture tonight. Now here's the story. John F. Kennedy, who changed his shirt 5 times a day, was a consummate negotiator of that vast distance separating image and reality. A distance more often than not reflected through media. In 1961, after Yuri Gagarin's dramatic orbit of the Earth and the globe's saturation in its surrounding imagery, it was Kennedy who sought the image of an American on the moon as the ultimate Cold War weapon. Kennedy asked, "Do we have a chance of beating the Soviets by a space program which promises dramatic results?" He didn't even just ask it, he demanded it of Lyndon Johnson, titular head of US space efforts, only 8 days after Gagarin's flight. 2 weeks later, at a meeting of the Departments of Defense, State, NASA, and the President's office, it was agreed that a manned lunar landing was the goal likely to have, quote, the clearest impact on the global imagination. As a result, by 1968, NASA's Apollo budget swept up almost a nickel from every tax dollar and created 500,000 jobs throughout a complex infrastructure of contractors and consultants in 46 states. A literal tracing of the architectural legacy of the Apollo effort would be to follow every gunmetal desk, hung ceiling, and warehouse truss underwritten and paid for by this vast enterprise. But at mid-century, architecture was by then already an enterprise of image creation itself. By this measure, that is, architecture and its production as a distinctive form of media, the story of the architect in the space race, a story of the architect in the space race emerges that is particularly relevant, I will argue to you tonight, to our present historical moment. In the international architectural literature of the late 1960s, there is a deep fascination with the image of man-machine. Take, for example, Buckminster Fuller devotees John Monchaux's extended essay in the February 1967 Architectural Design, in which the prosthetic possibilities of the space age anchor a 40-page report on space exploration and its potential off-world inhabitations. In this realm, the astronaut becomes, to quote Roland Barthes, nearer to the robot than the hero. And if not a hero, then at least a myth, a figure who, like the first man in Joseph Rickwert's On Adam's House in Paradise, incorporates architecture with all its protection, enhancements, and extension as part of himself. But here's something curious. In American architectural publications of the same era, we find nary an astronaut, nor, as might be more literally expected in the American popular architectural media, a discussion of the implications for the profession of architecture of this new literal architecture of space, capsules, suits, etc. In its place, there appears a deep preoccupation not with the ends of the Apollo program, but its means, specifically the prospects in architecture for what was called systems engineering. The organizational backbone of Apollo, systems engineering was a design method developed first for the Atlas and Titan ballistic missile projects of the 1950s. There, under the direction of Air Force Lieutenant Colonel Bernard Shriver and Seymour Ramo and Dean Wooldridge, the latter founders of what would become defense contractor TRW, a systems of standards, communication, and calculation was developed to synthesize the separate organizational effects of military, industrial, and academic collaborators, and to optimize solutions to the enormous complexity of a ballistic missile apparatus. Echoing the contemporaneous revolution of Dior in fashion, this systems architecture was termed, at the time, Eisenhower's new look in defense. The resulting intercontinental ballistic missile effort was adapted as a physical and organizational reality into the complex collaborations of NASA, even as, at Eisenhower's own direction, the assemblages of multiple military branches, contractors, and academic institutions were literally whitewashed together and labeled only USA. In remarks at the Smithsonian in 1968, U.S. Vice President Hubert H. Humphrey declared, quote, "The techniques that are going to put a man on the moon are going to be exactly the techniques that we are going to need to clean up our cities." Humphrey pointed especially to the systems analysis approach. Now, 40 years later, we are used to the complexity of putting a man on the moon as a ready comparison of difficulty. But this was not Humphrey's point. He imagined the precise techniques of the space race, so apparently successful in taming the complexity of large-scale man-machine systems, as a proven panacea for the parallel problem of man and machine represented by the city. Most literally, this transposition was visible in the co-opting of NASA personnel and resources into urban programs. A vivid but far from isolated example being the trundling of defunct Apollo mainframe computers from NASA headquarters down Constitution Avenue to the rising shell of Marcel Breuer's new Housing and Urban Development headquarters. Now, the relationship between HUD and an Apollo-era NASA had first been consummated with a 3-week summer study session at Woods Hole on, quote, science and urban development. The resulting report juxtaposed images of urban disorder with the ordered constructions of the space race, and so, even without direct association, left a clear implication as to the applicability and urgency of co-opting NASA's techniques. The report proposed, quote, creating a safe, happy city is a greater challenge than a trip to the moon, because urban housing is more complex than a rocket, and a city is subject to more perturbations than the moon. Its ever-changing problems, nevertheless, can be attacked in the same logical way we have gone about exploring the universe. By the onset of the Nixon administration in 1969, the intellectual exodus became literal. Computers were jointly operated, and senior NASA officials, most notably Howard Finger, former head of NASA's Space Nuclear Propulsion Office, were appointed to management positions at HUD, where Finger became Assistant Secretary for Research and Technology. The program Finger managed, called Operation Breakthrough, was one of the largest and most literal attempts to bring American architecture into the space age. Conceived of as literally analogous to the Mercury and Gemini programs, which tested systems and techniques prior to the all-out moonshot, Operation Breakthrough sought to craft a set of technically advanced prefabricated housing systems and then imagine the extension and aggregation of these dwelling units into new suburban communities. Yet Operation Breakthrough was far from the only direct connection between the military-industrial systems engineering of the 1950s and urban systems thinking of the late 1960s. Some other examples. In 1968, Jay Forrester, who had crafted the nation's first defense shield for the Air Force in the 1940s and 50s, called SAGE, finished work on his latest manuscript, called Urban Dynamics. While allowing that the text made, quote, no reference to existing urban literature, end quote, the work used digital simulations of complex urban processes to forcefully advocate new scientific approaches to planning. In 1968, RAND, the Santa Monica think tank, which had provided a bridge between the Air Force and industry, opened an office in Manhattan under exclusive contract to the Lindsay administration. And by the same year, Bernard Shriver, who supervised the Atlas missile project for the Air Force, we saw, was proprietor of a Washington, D.C. consulting firm called USA, or Urban Systems Associates. The firm sought to consult with both government and industry in partnership with defense contractors, including Lockheed, Northrop, and Raytheon. Most directly of all, in 1967, the Lunar Landing Simulator, developed by General Electric for NASA, the world's first three-dimensional digital space, was adapted by the Department of Transportation and UCLA Professor of Architecture Peter Kemnitzer to study the form and disposition of the modern city, complete with tower blocks and elevated highways. Inherent in it all was the notion that the interplanetary frontier of the space race would be supplanted by the urban frontier as the subject of systems engineering, and that the extremes of urban disorder would subject themselves to the same systems approach that had the extremes of lunar and translunar space. The apparent contrast between European and American architectural representations of the space race is fascinating in and of itself. Yet these two seemingly separate architectural legacies of the space race, that is, the visually exuberant blurring of man and machine on the one hand, and the systems management approach to building and urban development on the other, may be instead two sides of the same space-age cybernetic coin. Quote, it is proposed that man should use his creative intelligence to adapt himself to the space conditions he seeks, rather than take as much of Earth environment with him as possible. This is to be achieved through the cyborg, an extension of organic homeostatic controls by means of cybernetic techniques. So asserted the paper, Drugs, Space, and Cybernetics. delivered at a 1960 conference on psychophysiological aspects of spaceflight, organized by the U.S. Air Force at its new School of Aerospace Medicine in San Antonio. The authors, shown here, were Manfred Clynes and Nathan Klein, and they worked at New York's Rockland State Psychological Hospital, a 10,000-patient facility revolutionized by Klein's discovery of reserpine, the first antipsychotic medicine used in the United States, and iproniazid, the first monoamine oxidase inhibitor, or MAOI, used to treat depression. On the crest of the resulting deinstitutionalization that came to characterize mid-century psychiatry, Klein and Clynes, who Clynes was a researcher in cybernetics and analog computing, combined their backgrounds with the existing language of space research, which had already described a, quote, man-machine system, to coin an intellectual and etymological neologism. This cyborg was initially pharmacological, building on their experience revolutionizing the physiology of schizophrenia and depression. Exposed to the cultural and institutional atmosphere surrounding spaceflight, however, the concept became increasingly electromechanical. It found itself the subject of a multi-year United Aircraft study for NASA and a generous spread in Life magazine. The spread showed Clynes and Klein, and thanks to illustrator Fred Freeman, a pair of cyborgs on the moon, complete with silvery hard skin and quasi-architectural cutaways, showing machine and organ enmeshed. I would put it to you. Yeah?
I'm sorry. What are you giving us the chronology of? I'm just really lost.
I hope I will show you. I'm giving you basically a chronology of how two things which appear separately, which is to say discussions of systems in the body in the context of the cyborg, shown here and shown on the cover of that architecture magazine, and on the other hand, the discussion of everyone getting really excited about systems engineering in the city. These two things appear very separately if you look at the history. And what I'm building towards is an argument that, in fact, through this lens of cybernetics, which was a whole theory of how technological man-made systems could be talked about together and in the same terms, how these two ideas actually were part of the same coin. And it's part of a larger argument about how the city and the body are related historically and organizationally, and also related in the space age. Does that answer your question?
Yes, thank you.
Awesome. Okay. So I would put it to you in that regard, especially, that the popularly imagined cyborg is the quintessential citizen of the space age. Manifestly unlike the missile systems they repurposed, the manned rockets of the mid-1960s were habitats, at least ostensibly, hospitable to man. By incorporating manned capsules into the ballistic architecture of spaceflight, the systems architecture of NASA in particular implied the inclusion of habitat into the expertise and calculation of systems engineering in a way that academic argument alone could not. While the cyborg dreams of Clynes and Klein seem initially more fiction than science, man in space or architectural utopian figure is a type that we can trace well into the present. Take, for example, urbanist Michael Sorkin's assertion that the AX-3 experimental spacesuit, shown here, itself a descendant from prototypes developed for later Apollo missions, was, quote, one of the most beautiful designed objects I've ever seen. The suit, Sorkin continues, is sublimely functional, an apparatus of liberation, extension, of genuine prosthesis, the body simultaneously extended and housed. The notion of liberation espoused by Sorkin recalls not only the utopia of the cyborg, which Clynes and Klein argued would provide a, quote, new, larger dimension for man's spirit, but also the parallel language of systems architecture in an urban context. Like any utopia, the cyborg world has at its core a notion of the city. Quote, as truly as a spaceship, a city is a product of men's thinking that can be overhauled, rebuilt, and improved. The solution, it was asserted, quote, again from the NASA report that I quoted earlier, is information processing. Now, while the programs that resulted from this sensibility, like Operation Breakthrough, had a debatable impact on the earthbound housing industry, a final footnote to the space age origins of these ideas is provided by a post-Apollo strategic plan for U.S. space stations called Space Settlements, a design study. produced by NASA's Ames Research Center as a parallel activity to that suit design that I showed you in the previous slide, the 1975 study identifies systems developed for Operation Breakthrough as, in turn, especially suitable for building in space. Drawing on the same space station research exploited by Kubrick's 2001, the habitat proposed by NASA would house 10,000 astronauts, optimized by age and gender, and, quote, settled by persons from Western industrialized nations. In the renderings accompanying the proposal, the components of systems building are seen perhaps in their only native soil, a perfectly managed, balanced world entirely subject to, quote, principles from government and industry. The reduction or extension of architecture to an automatic cybernetic response to the environment, whether internal or external to its subject, recalls the contemporaneous collages of the Italian architectural group Superstudio. It is a notion of architecture that is both everywhere and nowhere, a total landscape. And like any utopian dream, it is transparent. Utopian modernist dream, that is. It has the quality of transparency, but in this case, as befits the shared cybernetic origins of both ideals, this transparency is not a physical form, or even phenomenological experience, but a transparency of control, which is, of course, the underlying idea of cybernetics. The liberation espoused, especially by Kleins, in the presentation of the cyborg ideal, he asks, quote, imagine what leaps a ballet dancer could do on the moon, is explicitly derived from the challenges of maintaining, addressing, or defending the physical health and protection of one's body and its immediate environment. Equally, the computed city of the new urban frontier was once realized a cyborg-like model that would be free of the burdens of planning and the chief bugbear of uncertainty, decay, and entropy. The truth is, as usual, much more interesting. If, as Hubert Humphrey suggested, the techniques that allowed a man to walk on the moon were truly those with the most promise for America's cities, we might, retrospectively, tell a slightly different story than that projected by Kleins and Klein in the cyborg dream, or that, indeed, of the timeless vision that came from the hard engineered spacesuit so beloved by Michael Sorkin. It turns out that despite the continuously articulated preference of both the military and NASA for technologies, including spacesuits, that extended techniques of systems engineering into the human body, the A-7L spacesuit worn on the moon by Neil Armstrong and Buzz Aldrin was a soft, multi-layered assembly of fabric and latex. Instead of being produced by a military-industrial contractor, the suit was produced by the International Latex Corporation, known better by its brand name of Playtex. And instead of being planned, engineered, and assembled by men, the suit was stitched, fashioned, and crafted by women, taken directly from Playtex's other soft good assembly workshops. Although finally fashioned as part of the larger apparatus of the manufacturing corporation, the women of the Playtex spacesuit shop floor were neither interchangeable nor replaceable. In fact, for several stages of the manufacturing process, there are only 1 or 2 women in the world with the requisite technique to produce a component that would meet the firm's rigorous standards. For such an incongruous adaptation of production values to succeed in the masculine, ideologically automated, and high-performance atmosphere of Apollo, others had to fail, and fail spectacularly. After responding with the only successful submission to a 1962 RFP for the Apollo suit, Playtex was then subcontracted to a United Aircraft subsidiary to continue work. When the conglomerate sought to rid themselves of Playtex as a subcontractor in 1965, it was only through the intercession of NASA suit technicians that the bra maker found their way back to the resulting 6-week trial. When technicians inflated a competing suit, a revised version of the Gemini suit, to Apollo's operational pressure, the helmet blew off. When Hamilton Standard's suit, when the United Aircraft suit was tested on a prototype from lunar lander from Grumman, its shoulders were too far to fit back into the lunar lander, trapping the astronaut on the moon forever. In designing the Hamilton Standard suit, or this was the United Aircraft subsidiary, for this competition, the conglomerate's engineers had abandoned the fruits of their collaboration with Playtex and started from scratch on a suit they nicknamed Tiger. Thanks to its system-based design, it was figured, mathematically, to be easier to use and less likely to fail than the previous Playtex design. Yet the very same features that led to this efficiency on paper, such as redundant pressure layers and highly mechanized joints, made it almost impossible to use the suit in practice. Usage tests on mobility, comfort, and exertion, crucial in the constrictive suits, favored the Playtex suits against all competitors by such a wide margin that NASA had no choice but to engage the unlikely supplier. As the craftswomen and engineers of Playtex sought to fit their own adaptive process into the systems architecture of NASA, one of the numerous sticking points was the role of representation in the design process. In traditional engineering, and especially in the web of systems relationships endemic to Apollo, first one draws. That is to say, first one establishes conceptually, and then one establishes in fact. In the workshops of Playtex, however, where iterative suit designs were tested in prototype directly on and around the bodies they sought to protect, a process of representation before the fact played a minor role. When it was made clear to Playtex that a full roster of drawings was part of their contractual obligations to NASA, those drawings were produced, but after the fact. Disassembling and dissecting the layers of fabric, reinforcement, and construction, the drawings are not generative, as a normal architectural drawing, but analytical. Like an urban atlas instead of a new town plan, the drawings perceive rather than predict. Now, this conflict went all the way down to the surface of the astronaut's own skin, and in particular to the assertion by NASA that all suit parts, no matter what size, needed to be given a different serial number instead of, as Playtex sought to assert, being sized small, medium, and large. And I swear to you, I'm not making this part up. The Playtex ultimately won because of the impracticalities of trying to engineer the sizing of the human body. And every component of the spacesuit was sized small, medium, and large, except for the urinary collection device, which, after an incident with the first astronaut fitted, whose name I promise not to reveal, it was sized large, and extra, extra large. Now, a final lesson of media is particularly memorable. In an effort to retain its contract in the face of NASA's attempt to switch to hard suits manufactured by Litton Industries in this case, which borrowed fundamental technology from the AX suits I showed you, Playtex made a continuous series of improvements that were as complex and impenetrable to a traditional engineering process as they were vividly helpful in the suit's growing mobility. Nervous that a sea of statistics would envelop NASA's deliberations once again, ILC sent along with measurements of its improved suit mobility a 16mm film of an engineer in a fully pressurized suit playing that most masculine of games, football, on a Dover, Delaware high school field. The image succeeded. ILC crafted second-generation Apollo suits as well, leaving hard masculine competitors such as those produced by Litton on the ground. The fact that those hard suits, ironically, remained the vision of man in space and of the future of man in space was immaterial to their operational failure. For example, the final prospect facing visitors to the 1970 Osaka World's Fair, a year after the lunar landing, was not the Apollo suit, but a selection of these failed hard suits against a coarse halftone of lunar canyons, which you can't quite see. The morphology of the final Apollo soft suits contained from 21 to 29 separate layers of fabric. Each was constructed of an earthbound material that imbued the suit with properties like flame retardance, heat retention, or the ability to maintain pressure, which recalled not at all the precision diagrams of the rest of Apollo's systems, but the adapted, multiply redundant, and interrelated systems of the body, that is to say, of the astronaut it protects. Now here we come back to the city, for when in the last chapter of her 1961 opus, called The Death and Life of Great American Cities, the chapter itself is called The Kind of Problem a City Is, urban activist Jane Jacobs sought to articulate a metaphor for urban planning distinct from the quote, collection of file drawers she abhorred. To do this, she turned to recent work at the Rockefeller Foundation, which had provided her with funding and an office to assemble her manuscript. There, her neighbor, Dr. Warren Weaver, was composing an essay for the Foundation's 1958 annual report, which specifically identified new thinking in the natural sciences, describing what Weaver termed, quote, organized complexity. Heavily quoting from Weaver's essay, Jacobs makes a case for the special affinity between urban landscapes and biological systems. Invoking the example of a single urban park, she submits that any attempt to isolate the variables, however many, leading to its success, is inherently dubious. Those variables are simply too numerous, too interrelated, and too interconnected. Here I am speaking as an architect, perhaps for the first time, but it's particularly interesting that the revolution in life sciences, forecast and spurred on by Weaver's essay, has prospered. And it is even more interesting to me in particular that much like the revolution in cybernetics and control systems of the last century, the language of this new revolution in organizational thinking is having a fundamental effect on the rhetoric and technique of the architectural profession. For example, in the 2003 monograph of their practice, Foreign Office Architects, Farshid Musavi and Alejandra Zarapola explicitly evoke biological science in their title, Phylogenesis. In the self-conscious classification of their project using the morphology of a phylogenetic tree, and in their effort to describe what they call the genetic potential of their organization. In two recent best-selling architectural monographs, Michael Hensel, Akim Menges, and Michael Weinstock of the Emergence Design Group at the Architectural Association in London lay forth an explicit agenda of, quote, morphogenetic architecture, relying on, quote, data, genes, and speciation. And in a 2004 essay, Carl Chu, head for the Institute for Genetic Architecture at Columbia, declares, quote, we are now in a position to articulate a more comprehensive theory of architecture, one that is adequate to the demands imposed by the convergence of computation and biogenetics, a monadology of genetic architecture. And that's a mouthful. Now, recalling, to my mind, earlier architectural fascinations with biomorphism, many of these self-consciously biogenetic adventures in contemporary architecture succeed in imagining a virtuosic continuity of form, albeit one that's internal only to the architectural object. Yet, as in the hard suits so beloved by Sorkin and NASA managers, but ill-suited to the body itself, the smoothness of a biocomputational systems approach comes with a conceptual hardness of systems and result, which is, I would argue, anathema to both Jacobs' original intent in introducing contemporary biology into urban theory, and to much current biological thinking as well. As such, it fails to appreciate the real lessons that such contemporary research in the natural sciences hold for design thinking. The architectural proposals associated with such language entice, as they imagine the body, in Sorkin's words, simultaneously extended and housed. Yet, whether the sustaining organizational principle of such forms is imagined as extending inward to the body from the precision systems management of an aerospace organization, or is more recently extending outwards as the continuation of a computationally imagined biological system, the result is the same. That is to say, to focus on a process or code of construction to the exclusion of the unexpected realities of urban as well as intimate space. Such a model misconstrues further the kind of a problem a biological system is, or at least is revealing itself more and more to be. For example, while DNA may be imagined as an architectural blueprint or systematic instruction in the popular imagination, the reality unveiled in the last century distinguishes organized complexity at the biological scale as being, in fact, much more complex. Recent work in evolutionary biology has shown that mutational change, that is, change in genetic instructions, is needed for phenotypic change, that is, change in the visible architecture of life. But some go as far to say that the two are simply not related. Well, the notion that genetic instructions optimize biological form is broadly correct. The belief that such a relationship is systematic, or simply systematic, and so contains direct analogies to the creation of form through blueprints, is far from the truth. Genes may have an effect, But this effect, it turns out, strongly depends on many other interconnected variables. Thus, far from occurring measurably or systematic, they are interconnected, numerous, and as Jane Jacobs said of the variables controlling an urban park, as slippery as an eel. Whether architectural gene or generative diagram, real genes do not perform directly or even transitively, but through a complex web of shifting relationships, disturbed even by our own observation of them. Such a web evokes not the city as we would design it, projecting forward with masculine brio. Rather, it recalls the city as we receive it, a fog of conflicting instructions and impressions, whose very vitality and visuality we threaten through the attempt to measure it, let alone seek its reproduction. In attempting to systematically appropriate genetic and biological metaphors for the creation of form, architects may seek an escape route from the more predictive and operational systems machinery of the last century, as exemplified here by the Bauhaus. But this rush to the future risks a U-turn. Biological evolution is a machine in the strictest sense. It truly does not know what it makes. But the simplified, systematized version of nature put forward by some in the architectural vanguards hides the very same hazard it would have us avoid. In seeking machinery for architectural production, and in particular for systematic novelty, the work hides a deep conservatism that recalls not nature, but the deterministic machine-like confidence of an earlier systems approach. Yet real nature, which as Jackson Pollock pointed out includes our own bodies and minds, would appear to have as its defining quality an ability to evade certainty and embrace the disordered fabric of reality as a grounds for adaptation, incorporation, and repurposing. It is these qualities that seem to define our most successful and thrilling urban landscapes as well. And so let me try and bring this in for a conclusion. Consider, first, a diagram of the Apollo life support system as conceived and illustrated by Hamilton Standard engineers in 1964. And secondly, an X-ray mobility study of the Playtex A7L spacesuit performed in January of 1965. The fundamental differences between these two images return us to the essential question of this talk. Why, and perhaps now how, was the Apollo spacesuit soft? The first image is both uncharacteristic and singularly representative of Apollo's interleaving military-industrial machinery. It is representative of Apollo in that it presents the human body as a streamlined outline, graphically receding in favor of a system of inputs, outputs, and cybernetic relationships of control. It is uncharacteristic because the human body is shown at its most extreme apogee of Apollo's journey to the moon, during a lunar extravehicular activity, or EVA. On the moon's surface, the body would be connected only to the portable life support system, or PLIS, as shown in the diagram, unfettered and physically autonomous from the vast infrastructure that was the foundation of its lunar trajectory. In Apollo's command or lunar module, by contrast, the astronaut's body would be literally hardwired, connected to sensors reporting pulse, temperature, and breathing to the desk of a mission control technician 250,000 miles away. It was only in the end, during the crisis of Apollo 13, that astronauts chose to disconnect this telemetry. The conception of the human body as a series of inputs, outputs, and controls is in turn representative of the cybernetic mindset of Apollo systems management. Conceived in the early part of the 20th century by Norbert Wiener to describe the phenomena of feedback, homeostasis, and control common to natural and man-made systems, the cybernetic lens was cast in wartime and would describe and control some of the most complex engines of destruction made by man. The great insight, after all, of Bernard Shriver, Sima Ramo, and Dean Wooldridge was to see the Atlas ICBM, the machine they first made, not as an object, but rather as a set of relationships, a complex system of informational and material exchange. To manage the construction of such a system, Shriver and his colleagues created an organization, a vast organization in the system's own image, a complex network of bureaucratic feedback and material flows wired into and out of the very same control rooms that would ultimately direct a nuclear weapons internal controls to its target. Once cast, however, the cybernetic lens of systems management was used to peer not just beyond the body, but reflecting as well as refracting back into it. As military industrial engineers sought to replace the warheads of system-designed ICBMs with astronauts, the most literal result of this view was the 1958 cyborg proposal, that the human body should itself be managed cybernetically for space travel, just as the missile's collection of valves, circuits, and cowlings was. This was a literal as well as lexicographic conflation of cybernetic controls and the human organism. The second image provides a marked contrast. Instead of a web of systematic relationships, we are treated to a specular field, a slice of the human body, an ILC spacesuit, or Playtex spacesuit, brought into focus on the surface of an X-ray. Here, too, there is an equivalence of natural and man-made, but, as in the nature of X-rays, the result is more than skin deep. A ghost captured by the machine, the layered assemblage of the Playtex spacesuit serves as both a mechanism to protect the body and also a recapitulation of the body's own structure. Encapsulating the skeleton, it abandons a system diagram in favor of the robust epidermal logic of the body itself. In 1969, systems engineer Simo Ramo published a book, Cure for Chaos: Fresh Solutions to Social Problems Through the Systems Approach. In a now familiar comparison, the book advocated the application of cybernetic techniques to the perceived disorder of its time. If we can give an astronaut good air to breathe on the moon, then why not in our cities? Ramo asked. Cities, he continued, do not constitute a good systems design. Redesign to make them better into a better overall system is not taking place at a sufficiently high rate. As we regard this comparison between systems organization and urban chaos, however, we should remember that the tissue of the body itself, even in the ghostly marrow of the X-ray, within this tissue, that is, interdependent networks eschew a logic of control for an interdependent logic of adaptation. Just as a human skeleton is an extended system for phosphate storage, as well as structure, so is the Playtex spacesuit an extended bra or girdle. Its new function, shaped in a demanding network of adaptations, still carries the trace of an improbable origin. Don't know how many of you know this, but the skeleton is evolved from little pockets that invertebrates had to just store phosphates, and then one day turned into how we stand up. This network of use and reuse turns us away from the pure logic of technology and towards one of tissue, the fragile layered membranes that are life's greatest strength. Here, incorporation within a complex collaboration supersedes invention within the systems of ideas and first principles. Something is made out of something else, both in terms of material but also structure. A spacesuit is made out of a flight suit, is made out of a Apollo suit and a Gemini suit, and also a Mercury suit, a bra, a girdle, a raincoat. An American rocket ship is made out of a nuclear weapon and a German ballistic missile. A space program, a new organization with new goals, is made out of pre-existing military, scholarly, and industrial organizations and techniques. Within this process of continual adaptation, there exist constructed and willfully iconographic landmarks, often built around images and mediated visions. For all their novelty, however, such new looks are but momentary glances upon a state of constant appropriation and transformation. An uncharacteristic image of astronaut John Young points further. Uncharacteristic because as he poses in a David Clark Gemini spacesuit in 1963, he abandons the heroic masculine posture rhapsodized by Roland Barthes as a natural aspect of the jetman. Instead, he vamps. And the humor, of course, is in the incongruity, the masculinity of the fighter jock, the femininity of the pose. But there is more here. A glance into the background of the image reveals a further organizational irony that resembles and reflects the humor of the pose. Arrayed behind Young is a collection of custom-fitted Mercury acceleration couches, including his own. It was only the provision of these custom-fitted chairs that allowed the systems design of the spacecraft to come within the Atlas missile's acceleration parameters. Recapitulating the later logic of the Playtex spacesuit, the men of Mercury were effectively mated to the system of military-industrial production not through cybernetic control, but couture customization. Unlike any other part of the Mercury spacecraft, the couches were literally and figuratively fashioned, custom fitted to each user and draped across their body in hard-setting plaster bandage before being molded in fiberglass. In some settings, such as in Mercury's couches, this juxtaposition between first principles and fashioning, the soft logic of the body and the hard logic of the system, can be seen as collaboration. But it was also fundamentally a conflict. This basic conflict is especially visible in a June 21, 1969 photograph of Neil Armstrong. Taken minutes after the conclusion of Apollo 11's EVA, it shows Armstrong return to the relative safety of the lunar module, having unfastened his spacesuit helmet. Visibly elated, Armstrong is also clearly exhausted. In a manner that would especially plague later Skylab astronauts, the systems and schedules that transported him to the moon's surface did so in spite of and not in sympathy with the logic of his own body. Armstrong is shown radically extended, not in the cybernetic sense of augmentation, but in the literal sense of physical distance and physiological exhaustion. Set against the control switches and visual austerity of the Eagle's interior is the essential conflict between electronic order and robust, intimate disorder that defines the special softness of spacesuit and spaceman. A different picture of spacesuit and spaceman, NASA image AS 11-405903 of Aldrin on the Moon, is one of the most widely reproduced images of the last century. Its chief subject, however, the Playtex suit, has been surprisingly absent from any design history related to man in space. As we have seen, instead, curators and critics have focused on prototypes that are often literally and always conceptually much harder. Whichever model of hard suit we choose, we perversely privilege the failures of fabricating clothing for space and not the successes. Now, the predecessor and namesake of Eisenhower's new look in defense spending was, of course, an equally revolutionary but very different new look, Christian Dior's. A 1951 Harper's Bazaar photograph shows the model Mary Jane Russell wearing the most extensive new look dresses in front of Turgot's 1739 map of Paris. Prepared prior to the radical surgery of Haussmann, the Turgot map is a particularly apt backdrop to the complex couture construction. The new look dress, of course, exerts a certain discomfort on the body of its wearer, shaping and even girdling it to fit the fashion needs of its own day. Yet in its multi-layered construction, it is also deeply sympathetic to the skin underneath its folds. In this sense, it is a physical as well as a conceptual parallel to the Apollo A7L suit, which we can consider in another less familiar image, on the body of Apollo 12's Alan Bean. In his unfinished arcade project of 1927 to 1940, the German critic Walter Benjamin produced a complex mapping of Paris in the 19th century, in an interlinked selection of crafted and borrowed texts. Benjamin's word for these linked and layered texts, convolutes, recalls conceptually as well as topologically the fashioned layers considered here, 250,000 miles from the French capital. In 1962, John F. Kennedy's intimate understanding of the gulf between the body and its observed surface led to a particular sympathy for and vision of the importance of space exploration, and in particular the image of an American astronaut on the moon. Yet, be it a picture of Camelot, Dior, or Apollo, we are not always willing or able to seek meaning under the surface that fashioned images represent. When we do, we discover that these new looks are, in fact, complex reassemblies of the old. Yet this is not just trickery. The oldness of the new is itself a special kind of novelty. The complex landscape of cities, or the near infinite biological web of the body, are both characterized by the same qualities of organized complexity, isolated by Warren Weaver in 1958. Subsequent study has revealed not only deep parallels between the complexity of cities and biological bodies, but also increasingly emphasized that, quote, there are strict limits to what can be predicted in the structure and behavior of each complex assemblage. In this sense, design for the body, as for the city, must take a different kind of lesson from nature than mimicking only its superficial shapes. Unlike architects, it is normal for a fashion designer to fashion. That is, to start carefully from the known to suit the body to a new circumstance, however radical the situation might be. In a different essay of Walter Benjamin's on the concept of history, the critic crafts a picture of fashion and urbanity that is again germane. Fashion, Benjamin reflects, has a nose for the topical, no matter where it stirs in the thickets of long ago. It is the tiger's leap into the past. This image, Tigersprung in German, fittingly captures the ceaseless appropriations and transformations that weave the fabric of our increasingly urban life. It is, as ever, a timely lesson. Now, if a single image rivals AS 11-45-903 for its visual proliferation in our culture, it is AS 17-148-22-727, the blue marble, a whole Earth. Yet, as with the Apollo spacesuit star turn, it is perhaps the intense reproduction of the image that hardens its surface to our view and helps obscure essential lessons of its content. Now, we are often told of the inspirational role of this image in the environmental movement on Earth, of the inconvenient truth represented by the borderless, interconnected globe. In fact, however, the image was as much a product of the green movement as a cause of it. Apollo spacecraft had captured images of the Earth's disk since 1968, but given the particular requirements of lunar exploration, these were necessarily of the shadowed disk of our own planet, obscured by the darkness of space. The need to show relief in the lunar surface on landing, as well as to land on that portion of the moon's surface facing the Earth to allow for communication, meant that the sun was by necessity oblique to both moon and Earth during all Apollo missions, meaning leaving both moon and Earth half full to inhabitants of either. This changed in December of 1972, more than 3 years after Senator Gaylord Nelson first proposed a nationwide teach-in on ecological relationships, and 2 years after John McConnell's flag with a painted full disk of the planet had become the symbol for the resulting Earth Day. Responding to critiques of the space program's relevance to an increasingly distressed situation on Earth, as well as hoping for the publicity that quickly evaporated from later Apollo missions, NASA approved several firsts for the last Apollo mission. These included the first non-military officer to be sent into space, the first night launching of a Saturn rocket, and crucially, a modified launch trajectory that would allow an unshadowed, full Earth to be photographed for the first time from space. Now, the wholeness of the image is familiar to us, but the particular quality of fragility it reveals is harder to see. As massive as our planet is, I worked it out, it's about 6 sextillion tons, the habitable environment of the globe is a fragile, tissue-thin atmosphere. The inextricably interrelated qualities of this atmospheric space, as well as the increasing urbanization that shapes it, are the fundamental issues of our own age. When Buckminster Fuller proclaimed a spaceship Earth in 1969, he evoked the nature of the Earth, like a space capsule or the lunar spacesuit, as a closed system in the celestial void. In the technological evangelism that characterized his enthusiasm, however, Fuller also sought to imply that, just like the Saturn V or the Atlas missile or the lunar module, the Earth's closed system could be contained and controlled by a single diagram, given only a piece of paper large enough. His late career efforts to create just such a world resources inventory and vast geoscope at Southern Illinois University can be understood as a literal attempt to create a ground large enough for this phantom figure to appear on. Following Fuller, we must indeed understand our world as similar to a spaceship. As in any closed system, we cannot escape the consequences of our own actions. But equally, we must recognize that the robust complexity that characterized our own body, cities, and planet will by its very nature subvert any attempt at diagramming or manipulating our environments with the precision of a spaceship's knobs or dials. As we face the necessity of transforming our own relationship to our only enduring spaceship, such a lesson is particularly essential. As the impact of human civilization on our robust yet fragile planet becomes ever more apparent, so we must resist the seeming simplicity of the system solution, as, for example, in recent proposals to solve global warming through systematic and global geoengineering. Much as the Playtex spacesuit created a suitable space for man in the extreme landscape of the moon, so we must carefully, if sometimes radically, fashion a space for ourselves on Earth. It has been the aim of this talk, now almost finished, I assure you, to argue that the softness of the Apollo spacesuit is indicative of a special affinity between the bodies of Apollo's astronauts and the spacesuits that protected them, especially as differentiated from the remainder of Apollo's vast systems infrastructure. As such, their iconic image should project not, as is traditional, a mastery of nature through technology, but rather a necessary sympathy to those parts of nature that, like our own bodies, defy control. 25 years after walking on the surface of the moon, the normally reticent Neil Armstrong wrote his own letter of appreciation to the Playtex suit and its makers. The sentiment alludes to this essential point. The suit, Armstrong wrote, turned out to be one of the most widely photographed spacecraft in history. This was no doubt due to the fact that it was so photogenic. Its true beauty, however, he expounds, was that it worked. It was tough, reliable, and, this is Armstrong words, cuddly. And now the last, but possibly even better argument for this particular nature of the suit's significance is a matter not of poetry, but of history, the continued attention of the astronauts to their spacesuits above all other surviving artifacts of the space age. When in Washington, Apollo's elite alumni are frequent visitors to the Smithsonian, but not to the vast Air and Space Museum that is the country's cathedral to its own space age mythology. Rather, they travel regularly to an anonymous warehouse in Maryland, where the surviving Apollo spacesuits rest in storage on beer-like shelves. The suburb is quite coincidentally called Suitland. Unlike the rest of Apollo's hardware, it is clear, Apollo astronauts regard the suit as an extension of their own selves, and not as a vehicle or container for them. Indeed, much like bodies, but unlike traditional hardware, the suits continue to change shape, size, and material as their living latex surfaces continually adjust to the Earth's atmosphere. So even as it represents a literal extension of a single Apollo astronaut's body, it is the lifelike quality of the Playtex spacesuit, its physical, material, and robust organization, that makes it represent all of our bodies as well. And so, as we gaze upon the fabric of the Playtex spacesuit, all of us can look on the world with Apollo's gaze. Thank you. I realize that was a lot, but I'd be happy to take a question if there was one. Yeah.
Yes. Maybe you'd be willing to elaborate on feedback a little bit. On feedback, and you make a distinction between prediction and perception.
Right.
And but perception but you ask us to consider consequences.
Yeah.
So perception, consequences, sort of marches you towards some kind of feedback, not necessarily systematic. And to just use your own language, is softness sort of a less hardness, or are there some particularities to softness that you'd like to talk about?
Well, I would say that this notion of inherent and this is deep in the kind of DNA of architectural culture, is that a notion that we can predict the world flawlessly and present as if it already existed a perfect vision of how it will be. And so architects are particularly susceptible to kind of buying their own mythology and imagining that the world can be shaped in particular ways. Now, of course, we have to it's much like the task of the translator. It's impossible, but we have to do it. We have to imagine and predict the world as it is. But I would say here is where this talk is called Fashioning Apollo. And fashioning, speaking etymologically, fashion is a great word because fashioning means it's both superficial and it's also very deep. It talks about making, but fundamentally it talks about making something out of something else. Like MacGyver fashions a bomb diffuser out of a paperclip, and therefore it's talking about being especially perceptive of the problems you have at hand, but realizing that the solution an optimized solution, which as in the case of MacGyver, we may not even have time for in our current ecological circumstance, is always going to depend on a kind of a set of measurements about the world, which we can, even if we can believe the measurements now, we can't necessarily believe them going forward. And I think a particularly insidious, I mean, I'm a designer, and I think the fundamental design issue of our day is the stuff that's coming out again, revamping 1960s systems engineering proposal for managing our way out of the climate change issue through vast iron deposits in the ocean, or whatever the latest thing is. We had some spectacular proposals in the 1960s for zapping the Van Allen belts with nuclear weapons to alter the climate above Russia, to affect wheat production, et cetera, et cetera. But of course, we all know that if that had happened, it's not just, presumably the Russian wheat would have been fine, and it would have been, corn in Iowa that would have actually been the problem. It's the nature of the world to work in these ways. And it's no coincidence that Murphy's Law was in fact invented in the context of the preparations for the Apollo program in human testing, because and therefore this constant feedback between reality. Feedback not in the sense of a diagrammatic feedback in the cybernetic system, but in the notion of just the literal notion of something feeding back into how one perceives the world, I think is particularly essential to this current moment in design. And I don't know how many architects in the audience, I probably should have asked before I started talking a lot about architecture, but especially in our current architectural moment, when digital systems of design can draw us very quickly into sometimes literally dragging a connection between an input and an output in a system for designing something. I think we need to be both particularly cautious about the notion that that measurement is reflective of reality, and particularly cautious of the notion that a kind of optimized vision necessarily represents the best response to reality. In fact, is often, as is, Stephen Jay Gould coined this term of when he was describing the natural world, of the architecture of adjacent possibility, which is to say the architecture of that which is adjacent to where we are now, but utterly different from it. In a way, in some ways more different from it than the things we optimize and imagine from scratch.
Thank you.
Yeah,
Thanks
okay.
for a terrific talk.
Yeah.
Is there a lesson here perhaps for, say, cars? Can we imagine a soft car? There doesn't seem to be a reason why cars are hard. Should we start with the measurements of the driver and fashion the car around them?
I think the notion that in some ways, it's very... one thing that the systems engineers of the 1960s had right was to always step back and imagine the larger system that something's a part of. So related to the car, I would say it's a mistake to imagine the car, to define the car as an object. As long as we define car as car, we'll have a lot of problems. But if we step back and maybe thought about a larger system of transportation and urbanity that the car could or shouldn't be part of. I mean, I have my good friends from Rebar sitting here in the audience who have done some spectacular work on the adjacent possibilities of parking spots that I'll just plug here on their behalf. But I think in terms of the car, for instance, a subtle but I think important example might come from something like the recent Dutch movement towards what they call complete streets, or the Dutch word, I'll mispronounce it, but it basically involves taking all markings and signage and regulations out of streets, which we think your first impulse is to say, oh my God, the whole system would, if it's not tightly controlled with these computers somewhere in town hall controlling when lights go on and off, everything would be a total disaster. But it turns out, in this complex negotiation of urban reality, that not only is everything fine when you stop trying to control the flow of traffic with computers, but it actually works a heck of a lot better, because the cars have to be really careful and always watch everything around them. The pedestrians can always imagine that a car won't just speed over them because the traffic signal is telling them that it's safe. And there's an enormous improvement in quality of life for everyone. If about a 15 to 20% reduction in throughput in terms of the car travel, but we measure the effectiveness of transportation networks still by these simple systems measurements, like the throughput of traffic in a highway system versus the quality of life and of the city that it's in. So it's probably not an answer to your question about the car, but yeah.
Were gender politics also involved in the development of the spacesuits in Soviet Russia?
Yeah, well, gender politics, I mean, both the Russian and American space programs were, I think, pathologically resistant to the feminine. It was at fundamental odds with what was going on. The Russians did send up Valentina Tereshkova as the first woman in space. She was the 6th Russian in space, I believe, but that was as much of a kind of a publicity stunt as sending 3 men into space, or sending, it was and if you look, there was a brief moment when there were female Russian astronauts, and there weren't female Russian astronauts again until the 80s, when the Americans started talking about putting women in space. So I wouldn't necessarily give the Soviets a free pass on that one either, but the Americans were particularly gruesome to women. There was a whole group of women called, when these, the first implication relative to this sort of Roland Barthes image of the astronaut as hero, the first propaganda efforts to expound what who these astronauts were going to be were that they were going to be the kind of summa or apex of physical achievement, and they were going to have to do all these amazing things. And it turns out, of course, that the Murphy's Law was invented in the context of measuring all the limitations to the human body, which were then had to be suddenly programmed into all these ballistic systems. And once those limitations were measured, once the actual tests were codified, a bunch of women were invited by the proprietor of the tests, a guy named Randall Lovelace, who ran a private aerospace testing clinic, to take all the same tests that the astronauts had taken, and no surprise, they did as well or better. So, and then the whole thing was instantly pounced upon by the Kennedy administration. Lyndon Johnson scrolled through the fabric of the memorandum about it. Stop this now! I mean, the paper is in shreds in the archives, and the whole thing was And then suddenly a new story of the astronauts' qualification is expounded, one which emphasized their test pilot credentials, or something that inherently women were not. But that's why I think the kind of masculinity, I think I've only, even in the book, scratched the surface of the gender issues involved here, but they're deeply fascinating.
I wonder if we could imagine some crazy situation
Yeah.
in which perhaps the space race had been relocated to the UK.
Right.
And instead of hiring the International Latex Corporation,
Yeah.
it swept all the tailors out of Jermyn Street who made bespoke
Right.
suits and involved them in the production of the spacesuit.
Well, essentially the same thing happened in the U.S. I told one particularly representative story in the book of Playtex, but when you see throughout it, I mean, when the Berger Brothers Corset Company was making, was the first, was drafted into making G suits in the Second World War. I mean, there's this kind of backdoor, the expertise about the body, came to particularly, especially because of the highly architectural quality to women's clothes. I mean, a men's suit has remained the same, essentially for several hundred years, and there's a lot more. Of course there's technique in a men's suit, but there's particular technique in, the weird thing. I mean, the weird thing in terms of gender politics is that the fundamental, it wasn't just any company. It was Playtex. Playtex's chief product was not bras as it became in the 70s and 80s. It was girdles, which were these like rubber tubes which you had to wear around your body all day that were surprisingly incredibly uncomfortable sweaty. I mean, who would choose to do that? It wasn't as if it wasn't a Playtex that was necessarily making its money off of techniques of liberation of women, but they did have this. But there's the architectural quality comes in too. I mean, Dior said when he spoke of his new look, without foundations there can be no fashion, and by foundations he very explicitly meant all these complex architectural undergarments that scrooched and tightened and did all these things to women's bodies. Yeah.
Are there, in light of the various sciences which are still emerging, such as nanotechnology and biotech engineering, and even sensor technology through quantum physics, do you know of any research where people are experimenting with new textiles where the suits move from perhaps the the organic quality of latex, I don't know if you call it organic, into something much more dynamic, much more flexible, much more integrated or connected to its environment, so that it keeps the space person better protected. And then I guess the second question is couldn't this not even just be for space, but eventually this might have to be used here on Earth in light of what's going on today, I think I'm wondering if there's any research being done in the design community and in the engineering community to think about these types of things.
Well, the notion, as you can perhaps tell, I'm both a massive technological optimist and also a technological skeptic at the same time. Technology does amazing things, but rarely what it says it's going to do. And so I would say that I think there are enormous possibilities in nano-engineered fabrics, in textiles, that they are the notion that the suit itself takes over the homeostatic function, which is what you were saying, turns out to have that was what the cyborg proposal was fundamentally about, was that somehow you had an architecture that took over this process of managing your body. But what I go into deeper in the book is that the very qualities that make the human body so resilient normally, I mean, we're incredible organizations and organisms and ecologies of bacteria and all these other things that make us work in incredible and unexpected ways. Those very qualities of interdependence are precisely what makes us so fragile when taken out of our normal, when taken above 35,000 feet. Basically, we have a very hard time, not just because we don't have any oxygen, but because of a myriad of other pressures, some of which we haven't even fully understood. And so that the notion that we would be able to take over all these functions presumes that we would be able also somehow to define them all. And to understand the precise and myriad ways in which our body works, and that's as successful as as all the systems proposals for engineering the body have ever been, from the cyborg proposal to the notion of artificial hearts to they tend to imagine there's a big mistake we make when we look at the world, the media of our own technology becomes the lens through which we see the world. So in a mechanical era, we see the heart as a pump. We think we can replace it with another pump. The Roman physiologist Galen wrote a long article, extended treatise on the hydraulic functioning of the brain, which, of course, the brain does not actually operate through the movement of fluids, but that was the state of the art of his own era. And so the notion, and we can look in present-day neurobiology and see a lot of people using words like buffer and packets and switching and always convincing themselves that they're actually describing what's happening, when instead they're taking a lens. And this is why, this is part of why I think to bring it back to the introduction, the Center for New Media is such a great place and such a great home for me on the campus, is that this notion of understanding this, in the first BCNM presentation I went to, Ken gave a spiel about how media comes from the Latin word lens, which is to say the thing that we see through and the thing that both allows us to see further, but also fundamentally distorts that which we see. And so technology is fundamentally a medium for experiencing and seeing the world that will always allow us to achieve incredible things, but always distort and reflect the world as we look through it.
Thank you.
Yeah.
Don't you, Nicholas, in some of your writings say that the hard suit, the Sorkin suit, was dorky, and that there was sort of that sort of lens that the soft suit, the playboy suit, looked more like was more heroic or something.
Well, no, I think the hard suits looked much more heroic to the people at the time. The RX series of suits, which were the Lytton suits that almost went to the moon, they were named RX because the head of the crew systems division pronounced them the prescription, i.e. RX, for spacesuit design, because they were deeply troubled. Existentially troubled by the notion of of a kind of stitched and that involved a technique that they didn't understand that the actual Playtex suit was sewn by hand to a tolerance of 1/64th of the inch. That tolerance existed only on one side of the seam, not on the other, and with 64 stitches to the inch, and needed to be assembled without pins or any form of fasteners. And I've sat down and spoken to the 5 women in the world who could do that, and they all ended up working for Playtex and building the suit. And there was a very and in fact one of the larger, more complex parts of the story that I didn't go into is the fact that not only were the women obviously not a part of the traditional system, but many of the men at Playtex were not part of this traditional system either. The head engineer for Apollo, for Playtex, was this guy Lenny Shepard, who had started out as the television repairman of the company CEO. And he was so handy that the guy, was like, well, come on down and why don't you help us? And he had a kind of and they called them, the military industrial guys called these guys hard knocksers, because they only had ever graduated from the school of hard knocks versus but then it became this term of respect within the country that, I'm a hard knockser.
But doesn't this suit end up where it is because it ends up being a better looking suit?
Well, there's a complex, I think there's a complex sequence of cause and effect in aesthetics. And so the suit has become iconic and has become iconographic. But that is, as another example, the silver color that the Mercury suits had, that was only there because in the suit that immediately preceded it, the X-15 suit, the company that made that had their suit dropped from the cover of Collier's because it was not photogenic enough. And so they put a silver coating on it to make it seem space age. And then every suit had to be silver because that became the iconography of the space age. Then, in the course of the Gemini missions, when they did the first spacewalk, they discovered that silver was actually a terrible idea in space. You had unprotected sun, shining all over the place in, astronauts' eyes. It was the worst thing ever. So they made them white, which reflects radiation, but scatters it spectrally, so it doesn't produce glare. And then, within 2 months, Buck Rogers went from wearing silver to wearing white. So, part of what the book tries to get at is that understanding coolness and fashion and media and the world of design as separate from the world of technology and exigency and engineering is a kind of cultural preconception that does not reflect reality at all. And in fact, the world is this kind of incredible miasma in which all these things are interrelated and mixed. And the fact that this suit, I think this suit is beautiful. And I think its kind of softness and kind of childlike proportions and then the amazing story of how it is the way it is deeply elegant, but it is not an elegance that convinced anyone at the time. And so I have to also understand that this suit itself has shaped my own notions of elegance to include it. Yeah.
Can you tie it back a little bit to the current, environment of urban planning?
Yeah.
Like tying back to the cities a little bit, because it almost feels like we're dealing with very similar situations as we were in the 60s, 70s, and any sort of concept of the Great Society hasn't even gotten to good yet.
Right.
So it's sort of like, we're coming to a point where we have all this knowledge, but it feels almost like we're emotionally hard and not emotionally soft. And so, but there's other kind of groups out there like the Greenbelt Alliance and other kinds of groups that are proving factually that there's less crime if you have like mixed races and mixed like socioeconomic like groups living together. Can you talk a little bit about like the information there and like what you see as sort of the vision for like current urban growth?
Okay, I think this is going to be the last question because I'm getting secret hand signals from Ken. But I think that I think it's, I'll make a plug, a very shameless plug for the work that I'm showing tomorrow night at Spur, and which is very much my own interest, very much in urban design. My appointment is here in both architecture and urban design, and which is to say, I don't necessarily think that work lives up to the grand rhetoric of this evening, but it is my attempt to say how does the presence of information and how does the fluency of information in the current age allow us not just to construct an idealized vision of reality, but rather to better understand, appropriate, and instrumentalize the very distance between the very interesting space that exists between a kind of system description of the world and reality. So the work that's showing its spur at the moment is a digital design method based on techniques that I discovered, looking at what HUD was doing in the 1960s for an interconnected ecological landscape for each one of 1,500 city-owned vacant lots in San Francisco that each adjust themselves to local variables, mostly thermodynamic, because you can't, I would argue that you couldn't attempt to adjust to or incorporate human variables without, in fact, opening up the technology and design of the system in a community-based proposal. But that's I think that the increasing presence of astonishingly powerful tools for computation and analysis and understanding of large-scale systems has some really promising possibilities for understanding for bringing the qualities of robustness and resilience to urban systems that they will need to survive the next century. From climate change to peak oil, it takes 64 gallons of gas per day to run Barcelona. The same number for Atlanta is 782. That's not going to, in 15 or 20 years, it's not going to work at all. And so I'm all for big questions in planning because we're faced with them. That's the reality. But the solutions we fashion for those we have to be careful because the system internal to itself is always going to present a picture of reality that's much more seductive to the designer and the planner, because it's one in which all inputs and outputs can be imagined, controlled, accounted for, and it is not the actual nature of place or cities or the planet. So that's probably a good note to end on.